Hey everyone, my name is Bryan Offut. I'm a product manager with MemSQL, and I'm here to talk about real-time machine learning with Kafka, MemSQL, and TensorFlow. So start off with a rough agenda, start off with some background, kind of what we're going to talk about today, provide some problem context, what's the data set, what are we trying to solve. Then we're going to go from 0 to real-time machine learning in less than 3 minutes. So right now I have nothing installed on my laptop. We're going to go through the full installation, get everything set up, and by the end we'll be doing some machine learning and be able to do some analysis on data. We'll leave some time at the end, key takeaways and questions. Probably won't have terribly too much time for questions, but I'll be hanging around the booth afterward. So what is this presentation about, right? We've kind of all been here all day, at least I have. We've heard all the words, big data, speed, data analytics, kind of all the buzzwords. So what is this presentation about? It's partially about those things. So the first question is, how can I train and classify data in real time? Can I do this without taking years to set up my environment, learning a ton about machine learning, learning a ton about all these different systems? How can I make this easy and quick? And can I train and classify at the same time, right? So lots of times you have your machine learning algorithm, you do a bunch of training, you host it somewhere, and then when you run classification through it, it's kind of stale. You know, what if I want to add, I have new training data that's coming in, and I want my algorithm to be updated with that new training data and classified using the most up-to-date version of the weights, whatever it might be. But really, this presentation is about a little bit more than that. It's about the big questions, right? You know, can I use statistics to answer one of the life's biggest and most inherently undefinable questions? You know, one of the things that makes us inherently human, which is love. So this may come as a surprise to many of you, but I am single. And like any reasonable single millennial with a math background, I was curious if I could use statistics to solve this problem. So I went online and I was able to find a real data set of speed dating results. So there was a professor at Columbia that wanted to do a sociological study on basically what people said they wanted in a potential partner versus what they actually wanted. So we had a bunch of people go through speed dates and mark people as matches or not. And beforehand they were asked to, they had 100 points, and they were asked to assign these 100 points to 6 categories: sincerity, attractiveness, fun, shared interests, ambition, and intelligence. And they were also asked to rank a variety of interests on a scale from 1 to 10. So this is stuff like yoga is one of them, movies, music, all of these sorts of things. And so I wanted to know, can we use this data, the answers to these questions, and people that actually matched in real life, these are real people, to empirically determine, one, a romantic type, identify potential dating matches as they come in real time, we'll see that in a second, and answer the question, like, how well do the machines know me, right? So I presumably have a pretty good understanding of my dating history and what I'm generally attracted to. So I was very curious, how close would this actually be to reality? So to do this, I used 4 technologies: Kafka, MemSQL pipelines, TensorFlow, and Docker. So pretty standard stuff, pretty commonly used technologies, nothing super crazy here. So a quick overview of the architecture. We have training data, so in a CSV. We have classification data, also in a CSV. That gets sucked into Kafka via 2 Kafka topics. We then use MemSQL pipelines to extract the data from Kafka, run it through pipelines transforms, which are going to run our TensorFlow code for training and classification. Then it's going to put it into the database, and then we can do some analyzing of the data in the application afterward. So just to give a quick overview of what the data actually looks like to make this picture a little clearer, person A answers a bunch of questions, person B answers a bunch of questions, they meet up, they talk for 4 minutes, and at the end they say, is it a match? If they both say yes, then it's a 1, otherwise it's a 0. And so for the classification, it's going to be person A plus myself. There's a wonderful picture of me that I took outside about 2 hours ago. And it will determine, is it actually a match? Cool, so let's take a look and see what this actually looks like in action. So the first thing we're going to do is start our MemSQL Docker image. So pretty straightforward. Just go ahead and run that. And then we're going to do the exact same thing for Kafka. Again, just Docker run. We have a Kafka Docker image. So if we go over here, we can do that. Oh, interesting. Let's unfull screen this then. And go over here. Cool. Yeah, so it's these, I just did this line, and so over here in the terminal window, we have Docker and MemSQL running. Then we have to make our topics. So there's a bunch of code here, most of which is copying over configuration files. There's nothing too crazy. What's actually interesting down here is we're making our 2 Kafka topics and then turning it on. So we go over here, and we can run that. And then we have some Python we have to install. The MemSQL, the transform of the MemSQL pipeline is written in Python, so just some libraries we have to install. Again, nothing too crazy, just scripting this to make it a little faster. And then once all of that is set up, we do the interesting stuff. So we're going to make a database called speed dating matches. We're going to create 2 tables, training and the actual results. And then we're going to make our pipelines. So MemSQL pipelines are going to stream the data from Kafka. And as you can see where my mouse is, this is actually pretty straightforward. I'll make it a little bit bigger for everyone. You say create pipeline, you give it a name. You say you want to load from Kafka. You give the IP address, and you give the topic name. And you specify a transform file. So for training, we're going to use a training Python file. And for the running, we're going to use a run model Python file. And then these are actually the arguments to those transforms. So we're going to give it an algorithm we want it to use, which in this case is linear classifier, and a directory we want it to save it to. So the classification algorithm is going to read from that directory to use that model, and the training is going to save results to that directory so that the classification can pull from it. Cool, so let's go ahead and run this real quick. Still installing some of the Python, but that should be fine. Oh, and we see that MemSQL has an issue. So something that's actually really interesting about the MemSQL Docker image is it will also spin up MemSQL ops. So if we go to localhost 9000, it's clear. We can very clearly see, oh, look, one of our nodes didn't run. So we can go over to our bash screen. MemSQL bin/bash. And we can go MemSQL ops, restart MemSQL. Oop. There we go. We restart all nodes. And so this should solve our problem. It's going to stop the cluster and start it back up. And we can actually see what's going on over here in MemSQL ops, which is really nice. So sometimes you'll see issues, and it's really cool to go in here and you can see, oh, cool, that node wasn't running. I should probably just restart things, and it'll pick itself back up. So we're starting up. And we see that they're now both running. And we can go over here and copy paste the exact same thing. And we've made our table. We've created our pipeline. And if we run show pipelines, we can see that the training is now running. Cool. So what is actually going on in this training transform that I've been talking about? How complicated is the code? Well, the good news is that it's actually very straightforward. There's 4 files. The first one is this model options file. This is a really simple convenience function. TensorFlow has these things called estimators, which are really awesome. It's like a very high-level API for running pretty basic machine learning algorithms. And this is just so that you can use this method to pick one of those things. So if we go back to when we made our pipeline, we put linear classifier as our argument. You could go and alter the transform and easily put in one of these and restart your pipeline, and you're good to go. The other one's a model variables file. So this is just we're reading from a CSV, what are the column names, and then setting up our TensorFlow features. So machine learning, feature vector, got to do all that. We have 2 types, categorical, which is going to be anything that isn't a continuous number. So like a color would be categorical. And TensorFlow does an awesome job of actually mapping those things to sparse vectors for you, which is really convenient. So you don't have to know how many different categories you have. And then continuous. So this is stuff like age, et cetera. We put these into a list because that's what TensorFlow actually wants as to pass into the method. And this is my answers to the questions. So nothing's there. So if we go over here and we select star from speed from dating training, I got a typo here. Cool. We can see that the initial training is done. Just has some information here, accuracy baseline, average loss, all that kind of stuff. So now that we've done that, let's go ahead and start our speed dating results pipeline. Cool. So now we show pipelines, and they're actually both running at the same time. So if new classification data comes in, it's going to run the same thing. When new training results come in, it'll do that. So what does the actual training code look like? So the training and run code are actually very similar. It's going to take in the input stream. The extractor passes the transform, this stuff, as a byte-encoded CSV. So this is just boilerplate for any Kafka transform that you're going to use. An input function, really straightforward. Yeah, and then basically all we do is read the CSV into a data frame, choose our model using the arguments we passed in, and then train it. And then we'll output some evaluation information, which we saw just a second ago. And run model is actually the exact same thing. Same boilerplate code here, same deal reading in the CSV, doing some stuff to combine my answers with other people's answers, choosing the model, and then instead of training, we're going to predict. So if we go over here, and we select star from speed dating, from dating results. Cool, we see that, and we can actually go through and do this. We have some results, right? So these are people that presumably matched with me, or did not match with me in this case. So I'm running low on time, so I'm not going to do too much of the going through queries, but to spoil the surprise, it's very, very good at predicting fairly correctly people that I would probably actually be attracted to in real life, which I found very interesting. So quick takeaways, so I can wrap this up here. Key takeaways here are, TensorFlow makes it pretty easy to do simple machine learning, right? At the beginning here, I had nothing installed, and by the end, we had everything running. Was actually able to do some machine learning and output some results. Pipelines in TensorFlow makes doing this in real time actually pretty easy. If we ran through and did a query again, you could see stuff was actually coming in real time. And love is NP complete. So while this is pretty good, there's a lot more factors at play here rather than shared interests. So just want to call that out. So thank you everyone very much.